We stand on the edge of a new technological era, one that promises to transform our world in unimaginable ways, an era driven by the incredible power of quantum computers. These machines leverage the bizarre and fascinating laws of quantum mechanics. They promise to revolutionize fields like medicine, materials science, and artificial intelligence, bringing advancements we can only dream of. Imagine a future where we can design life-saving drugs with pinpoint accuracy, or develop new materials with unprecedented properties that could change industries. Quantum computing has the potential to make all of this a reality, faster than we ever thought possible. This is not just science fiction, it is happening right now. Quantum computers are already being built and tested in labs around the world. They are being used to tackle some of the world's most challenging problems, from climate change to cryptography. This new era of computing is about harnessing the power of the subatomic world, unlocking its full potential. It is about unlocking possibilities that were once considered impossible, and shaping a future beyond our wildest imaginations. To understand quantum computing, we must first understand how it fundamentally differs from classical computing. Classical computers, like the ones we use every day, store and process information as bits. A bit can be either a 0 or a 1, representing two distinct states. Quantum computers, on the other hand, use qubits, which are fundamentally different. Qubits can be 0, 1, or both at the same time, thanks to quantum mechanics. This is due to a quantum phenomenon called superposition, which allows qubits to exist in multiple states. Imagine a coin spinning in the air, not yet heads or tails. It's not heads or tails until it lands. That's superposition in action. Qubits can explore many possibilities simultaneously, unlike classical bits. This unique ability allows quantum computers to perform complex calculations much faster than classical computers. For certain tasks, a quantum computer could find a solution in minutes, which is revolutionary. A classical computer might take billions of years to solve the same problem, highlighting the power of quantum computing. Superposition is just one of the strange and powerful principles of quantum mechanics that quantum computers exploit. Another is entanglement. Entanglement is a special connection between two qubits. When two qubits are entangled, they become linked. Measuring the state of one instantly tells you the state of the other, no matter how far apart they are. Imagine two coins flipping in perfect unison, always landing on the same side. That's entanglement. This spooky action at a distance, as Einstein called it, allows quantum computers to perform computations in ways that classical computers simply cannot. Entanglement is key to unlocking the true potential of quantum computing. Section 4. Quantum computing in action, real-world applications. The unique capabilities of quantum computers open up a world of possibilities, transforming industries and scientific fields. One promising area is drug discovery, where quantum computing can make a significant impact. Quantum computers could be used to simulate complex molecules with unprecedented accuracy. This could accelerate the development of new drugs and therapies, potentially saving countless lives. Imagine designing personalized medicine tailored to an individual's genetic makeup, offering more effective treatments. Quantum computing could make this a reality, revolutionizing healthcare. Another area with huge potential is materials science, where new discoveries await. Quantum computers could help us design new materials with unique properties. Materials with properties we can only dream of today, such as ultra-lightweight and super-strong materials. Imagine lighter, stronger materials for aerospace or more efficient solar panels for sustainable energy. Quantum computing could pave the way for a materials revolution, changing the way we build and create. Quantum computing can also revolutionize cryptography, ensuring our data remains secure. Quantum computers could break the encryption methods we use today, posing new challenges. But they can also create new unbreakable encryption methods, enhancing security. This is called quantum-safe cryptography, a crucial advancement for the future. Protecting our data in a quantum future is crucial, ensuring privacy and security in the digital age. Section 5. Challenges on the path to quantum supremacy. While the potential of quantum computing is enormous, challenges remain. Building and operating quantum computers is incredibly difficult. Qubits are extremely fragile. They are easily disrupted by their environment. This leads to errors in calculations. Another challenge is scalability. We need to build quantum computers with millions of qubits to solve the world's most complex problems. Currently, the largest quantum computers have only a few hundred qubits. Overcoming these challenges requires significant advancements in materials, science, engineering, and computer science. Section 6. The Quantum Future. A world of possibilities. Despite the challenges, the future of quantum computing is bright. As research progresses and technology matures, quantum computers will become more powerful and reliable. They will tackle problems that are impossible for classical computers. This will lead to breakthroughs in medicine, materials, artificial intelligence, and beyond. The quantum revolution is not just about building faster computers. It is about changing the way we think about computing and the world around us. It is about harnessing the strangeness of quantum mechanics to solve real-world problems. The quantum future is full of possibilities. It is up to us to explore them.